This video we will generate the trend line and dataset of the Chebyshev second kind polynomial. We'll use the trend line equation as the Chebyshev polynomial. Here we have the Taylor-Maclaurin series sum of the Chebyshev polynomial defined as y equals the summation of a times 1 minus x to the power k, where a, the coefficient, is negative 2 to the k times n plus k plus 1 factorial all over n minus k factorial plus 2k plus 1 factorial. And our values of k is from 0 to n, while n will be from 1 to 10. So data validation, list of items 1 to 10. So these are the values of n, 1 to 10. And our k is equal to sequence of n plus 1. One column starting from 0 incremented by 1. So if it is 1, the value of k is 0, 1. If n equals 2, the value of k is 0, 1, 2. The value of n equals 3, then k is 0, 1, 2, and 3. Now we can enter the Taylor-Maclaurin series sum. Array formula, series sum of 1 minus x raised to the power k, which starting from 0, incremented by 1. And the coefficient will be this range. Here's the trend line equation and the trend line, where we generate the Chebyshev second kind polynomial. And the coefficient will be starting from the numerator. So minus 2 to the power k. So if this is empty, this should be 0. So we have to correct this. So if k is empty, so if this is empty, equals empty, then 0, otherwise calculate. So we have corrected the problem. So this is 0 because this is empty. Now we can continue with the second term, which is n plus k plus 1 factorial. So times factorial n plus k plus 1, n plus k plus 1. And now the denominator. So we work on the denominator all over. First term is factorial of n minus k, n minus k, times 2k plus 1 factorial, 2 times k, that's 2 times k plus 1. So here's the trend line equation, which is also the Chebyshev second kind polynomial, and the trend line. Starting from 0, or n equals 1. At n equals 1, our Chebyshev second kind polynomial equals 2x. So y equals 2x. 2x. N equals 2. The Chebyshev second kind polynomial is minus 1 plus 4x squared. Minus 1 plus 4x squared. At n equals 3, Chebyshev second kind polynomial is minus 4x plus 8x cubed. At n equals 4, the Chebyshev second kind polynomial is minus 12x squared plus 16x to the fourth. At n equals 5, the Chebyshev second kind polynomial is 6x minus 32x cubed plus 32x to the fifth. At n equals 6, the Chebyshev second kind polynomial y equals minus x 24x squared plus 24x squared minus 80x to the fourth plus 64x to the sixth. At n equals 7, the Chebyshev second kind polynomial y equals minus 8x plus 80x cubed minus 192x to the fifth plus 128x to the seventh. At n equals 8, the Chebyshev second kind polynomial y equals 1 minus 40x squared plus 240x to the fourth minus 448x to the sixth plus 256x to the eighth. At n equals 9, the Chebyshev second kind polynomial y equals 10x minus 160x cubed plus 672x to the fifth minus 1024x to the seventh plus 512x to the ninth. N equals 10, the Chebyshev second kind polynomial y equals minus 1, negative 1, plus 60x squared minus 560x to the fourth plus 1792x to the sixth minus 2304x to the eighth plus 1024x to the tenth. This completes the use of Taylor-Maclaurin series sum to generate the expansion of the Chebyshev second kind polynomial and sequence, Array formula, and LINEST polynomial regression.